All right, so number 10 on this worksheet. Here we go, number 10. My picture's horrible. I don't care. A, B, C. All right, so first thing I did on every one of those problems, I looked at it and I saw what the information I was given. What is this? Is it side, 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 angle, side, angle, side, angle, 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 side? What is it? Or the other one? It's the one we can finally talk about in Trig, right? Now you're old enough. Side, side, angle, which means, oh, we got to be careful, okay? Got to be careful on this one. So why? Well, if you remember, if you have an angle and a side across from one another, timed together, if I'm able to tie anything together, what do I use? Law of sines, law of cosines? Law of sines, okay? That means I'm going to use sine of 91 over 28. And then what angle must I find? Why? Because I have the side opposite angle A. So I'm going to have sine of A over 14. Okay? Calculator. Hey, Braden, get ready. Let me get it here. Oh, sorry. Thank you. All right. So here we go. Calculator has to be in what mode? Degree mode. Be sure of that. So here we go. I did all of this stuff in the calculator. I'm going to cross multiply, and I'm going to go sine of 91 times 14 divided by what? 28. Now, that's going to give me, all right, here we go, 4999. 0.4999 equal to sine of A. How am I going to get angle A? I'm going to have to find the inverse sine of this number. So I'm going to find angle A by finding the inverse sine of that 0.4999 number. Now, when you look at the calculator, I'm not going to do anything to my calculator. I'm going to find the inverse sine of my answer, and it gives me 29.99, which is 30. Or 30.0. Megan, you need to see that because I know I didn't show my work. I did it all in the calculator. Okay? I was blowing that calculator up this morning. Watch it again. Sine of 91 times 14 divided by 28. And then I know if I have the sine of an angle, I have to find the inverse sine of my answer, and it's 29.99. Has everybody figured out how to put this in your calculator? It'll save you a whole lot of writing. Here I am telling you not to write everything down. That's not like me. Okay? But it makes it very, very easy. So we've got angle A is 30 degrees. What's the other piece that's going to be the easiest thing to find now? The other angle, okay? 180 minus 91, which we were given, minus 30, which we just found. That's 121. Is that 59 degrees? Okay? So 59 degrees for angle C. Clouds make me happy. Drawing them, not really clouds. And now, what else do I have to find? I've got to find side C. So now I'm still going to use the law of sines. Which ratio I'm going to use every single time? Sine 91 over 28. Because that was given to me. And now we have sine of 59 Isn't that what we're trying to find in side C? Nope. Yep. Sine 59 over side C. All right, Megan, you ready? All right, here we go. So I'm going to put all this in my calculator. Sine of 59 times 28 divided by who? Sine. And look what I did. Do you see what I put in there? Divided by the quantity. I'm afraid if I don't put it in there, I'm not a risk taker. I'm afraid my answer will be wrong if I don't put it. Okay? But it gives me that side is approximately 24.0. Does that help? And I had your paper, I'm sorry. Did you figure out what you did? Okay. Any other questions? Guys? Yeah, it's nothing new. The only thing new was Heron's formula, and that is so totally a formula that you have to know what's semi-perimeter, by the way. Half the perimeter. You have to find half of the perimeter of the triangle you're given, and then it's this big long formula. The square root of S times the quantity, S minus A times the quantity, S minus B times the quantity, S minus C. I think that's it. Isn't that it? It's just all calculator stuff. It's really easy. Okay? Other questions?
Our restaurant's right across the street. They always look and try to see if any of the ways to get there. Yeah.
I will. And it's a restaurant. Here we go. Simplifying trig identities. Guys, you're going to have to be able to transform problems. This is going to lead you into very difficult calculus problems, pre-calculus. So you've got to be able to transform. Assume. Well, let's put that. Simplifying trig identities will help us transform equations for calculus. So this is why you have to do this. And the thing you have to assume is you have to assume that all denominators will not equal 0. Why? Why will they not equal 0? If they are, what happens? It's undefined. Good. So we're going to be looking at a couple of identities, which you already know. And we'll be using these. This is like a puzzle to me. I don't like puzzles that you put together, but this, trying to figure out how to put these together or how to make them work out, this is like equations on steroids, okay? Well, no, this is like creatine on steroids, kind of, okay? So, it's just interesting, I think. First thing we're going to look at are reciprocal identities. And reciprocal identities are these. You already know that cosecant theta is what trig function's reciprocal. What trig function does cosecant go with? Sine, cosine, or tangent? Sine, okay? So cosecant is the reciprocal of sine, 1 over sine theta. Secant theta is equal to 1 over what? You already know this. 1 over what? Cosine. And then, of course, cotangent is 1 over tangent theta. Y'all with me? Yeah? You already know this. You also are familiar with quotient identities. What does quotient mean? Dividing, okay? So you already know that tangent theta is what two trig functions divided? What over what? You already know this. Sine over cosine. Very good. Right? You already know that. And you also know that cotangent, another way to write cotangent is what divided by what? Cosine over sine. Very good. So you already know these. I don't know if you have them on your card or not. Do you have those on your card? Yeah. Okay. Now what are we going to do with these? Pardon me? You should have that cosecant is this, secant is this, cotangent, tangent, and cotangent. You ought to have that on your card. Okay? Is it on there? Yeah, it's already on there. Should already be on there. Questions? Everybody have this? All right, here we go. So let's look at, to simplify algebraic expressions, if I were to give you something like 2x squared y plus 14xy to the third z, and I told you to simplify that, because that's an algebraic expression, what would the first thing you would do be? Skip it. No, you will not skip it.
Well, first I would
What?
Look at it.
The second term is 14xy cubed z. What? Take out the greatest common factor. We would factor the algebraic expression if possible. We'd factor everything if possible. Absolutely. And then you always want to have, just in case, if you had a rational expression, just remember that your denominators must always be the same. If you're adding or subtracting rational expressions, meaning fractions. Okay? You always have to have common denominators. And that would go back all the way to the first part of the Algebra 2 review that we did, okay, the very first part of the semester. Now, how does this apply? We're going to do the very same thing here, folks. Same rules apply to trig expressions. Same rules apply, okay? Same rules apply. Everybody got that? All right. Here's what you're going to see. Your instructions may tell you to simplify. No. I just wanted you to see if you couldn't remember what an algebraic expression. I wanted you to tell me to factor, so that's why I wrote it up there. Simplify and be sure to write everything in terms of sine and cosine. We have to write everything in terms of sine and cosine. So here is an expression. You ready? Cotangent theta, sine theta, secant theta. What's that mean? What operation, what mathematical operation is in between cotangent, sine, and secant? Multiplication. Okay, so we know it's multiplication. We got to keep this right here. We have to either put this in terms of sine or in terms of cosine. So this is like fancy substitution. How could we rewrite cotangent? It's got to be in terms of sine or cosine. All right, now let's think about that. If I rewrote cotangent as 1 over tangent, is that putting it in terms of cosine or sine?
Wouldn't you just divide?
No. What's the other way to write cotangent? Cosine over sine. Don't be so, calm down. Hey, guess what? We're going to work this week. Suck it up. Get over it. Here we go. Is sine in terms of sine or cosine? Yes. Leave it alone. It's already where it needs to be because it said to put it in terms of sine or cosine. We want to rewrite them so that it has sine or cosine in it. Secant. Can I rewrite secant in terms of sine or cosine? How can I rewrite secant? 1 over cosine. I got to write it as a reciprocal. How do you know they cancel? Oh, you did? For real? How'd you know that? You just said it. Okay. This is like a proof, folks. You got to tell me why. This is the why part. Cosine cancels. Sine cancels. So you're right. It is 1 over 1, which is 1. Say what? You know what? Braden, sorry. I'm just wondering if we could do this in the calculator. I don't know. We'll see. I don't know. I've never tried it because I like doing this. I don't know. I just do. Because it's going to give me the value of 1. So cotangent is the inverse of tangent. No, but x is fine. It's just the name of the angle. I don't know if this will work or not, folks. Secant is inverse cosine. No. Okay. Hey, hold up. Nope. I don't want that. I want the entry. No. Okay. So it won't work. I just thought I'd try it. Anyway. All right. Difficult, not difficult, whatever. Okay. No. It won't. They won't stay like that. You know that. All right. Here we go. Here's another one. Remember, we are writing these in terms of sine or cosine. Okay?
All of them except the other.
Explain what you mean. Which ones do I not have to change? Cosine and sine don't have to change, right?
Oh yeah, that's what I'm saying.
Okay. But tangent's going to be changed to what, folks? Talk to me. Come on. Sine over cosine. Did I not do that? Oh. What are we going to do now? Say what? No, why don't they cancel? That one's in parentheses, but that's not why they don't. I'm adding, so I can't cancel when we're adding or subtracting. Got to get common denominators. All right, so let's clean this parentheses up. Cosine t over 1 plus, I don't need the parentheses. When you're multiplying across, sine times sine is what? Sine squared. That is exactly what it is. Sine squared t over cosine t, yes? All right. Now, what did you say, Michaela? You said we had to get what? Common denominators. Folks, if your denominators are 1 and cosine, what's your common denominator? Cosine. All right. Here we go. Oh, come on now. Suck it up. You'll be all right. What did I multiply to the bottom? Cosine. So what do I have to multiply to the top? So that means I'm going to bring this cosine down, and I have to multiply another cosine to it. Cosine squared. Oh, looky, looky, looky. No, well, you can. I'm not going to. Nope, I don't. I show all my work so you can look through. I show so much work, you ought to be able to look through my work and figure it out on paper. You shouldn't have to be able. No, I don't. Y'all don't do enough work. Suck it up. Okay. Say that with love. Always. Okay. Hey.
On our card, we have like sine, cosine, tangent, and inverse, but we only have tangent and sine because I don't have the other four.
Put them on there. Do you see anything else going on here? Once I have, just put them on there. Just put them on there. We have like denominators. What can we do when we have like denominators, folks? When I have something that looks like this, excuse me, what can I do? I can add them together. So folks, add the numerators together. Cosine squared plus sine squared, bless you, over 1 denominator. Now, look at your card. You have a bunch of Pythagorean identities on there. Do you have anything, oh yeah, that is equal to, that would clean up this? What? Cosine squared plus sine squared. What's that equal to? Oh, looky, looky, looky. Here to here. Look at your card. Which identity is that? That's your Pythagorean identity. Guys, that's why you had to have those identities way back when. The Pythagorean identity is going to be your best friend. If you can get anything down to cosine squared plus sine squared, or sine squared plus cosine squared, then it comes out and it's 1. Pardon me? What do you not get? Why is it 1? Because what is your Pythagorean identity? Pardon? Pythagorean identity does not say cosine squared plus sine squared equals 1.
Mine says cosine squared t equals the other side.
What? What?
I got mine.
You found it? Okay. So you see, all we're doing is fancy substitution. And folks, can you clean up 1 over cosine t? It's a what? Secant. That is the reciprocal of secant. So either one, this is like going from 2/4 to 1/2. That's what that's like, okay? It is not supposed to be. This is an advanced math class. It's either one of these. It's either 1 over cosine t or secant t, because they're the same thing. No, you're not getting extra credit. Do your job. Welcome back. Okay? For sure, you better do your homework. Here we go. Look at this one. Cotangent x times cosine x plus sine x. See what you end up with there. Yeah, do this one. No, you don't need, follow the last example. You do not need me to take you through this problem. This is very simple. You got to do it. Helpful. How do I do it? What do I rewrite first? Cotangent, rewrite it as what? Cosine over sine. Do I leave cosine the way it is? Right. All right. Plus sine over 1. Everybody agree with that? Okay. What do I do next? What's my next step? Multiply. Multiply this stuff right here. Cosine squared over sine plus sine. Now I can cancel my sines, right? Why not? Because I'm adding. What do I do? Common denominator. Good. What's my common denominator? Sine, of course. This one doesn't change. If I multiply sine to the bottom, I have to multiply sine to the top. So what's sine times sine? Sine squared. Skipped a step, Devontae. Proud? Thanks. What do we do now? Write it as one fraction, okay? Here we go. Cosine squared x plus sine squared x over sine is why? Because of the card. What is this? That's your Pythagorean identity, which is on your card. And then can I rewrite? And what you can do, folks, is just leave it. 1 over sine of x, or how can you clean that up? What is that? So I could write it without it being in a fraction. Cosecant. That's why I would do both. That way you're safe and you're covering your hind end. Okay? Either one. If I were to give you this, and again, just like in that last problem, if you were, would you leave an answer as 2/4? No, you wouldn't. You would clean it up and make it look nice, and you would reduce or simplify to 1/2. That's the same thinking. Okay? Questions at all? I seal, Diffie seal. It's coming off of your card. Is it on your card? All right, what we are trying to do is there it is. That one. Yeah. Now, guys, you know those 6 other identities? Are we going to use those? Yeah, we're going to use them at some point, okay? But the Pythagorean identity, the main one, we're going to use it all day long, a lot in the next several days. Questions? How many of you had that? Hands up. Awesome. Great. I'm telling you, if you feel like shutting down this next week, go ahead. You're going to have grades, and you do what you need to do, but do not come in here whining when your average drops. Go ahead. I'm sorry. x divided by cotangent. Now, what do you think I'm going to do with this? What do you think Miss Perry, is going to do with this problem? Because it's division. How would I rewrite it? Before I'm able to multiply by the reciprocal, what do I call that? No. It is rewriting, you're right. But how would I rewrite this? I would go old school. Old school division, which is what you're talking about. Cosecant x over 1 divided by what? Cotangent over 1, right? Okay? And that's what you meant, probably. Maybe. Sure. Can I rewrite cosecant?
No.
Because what is my objective? My objective is to cancel out as many things as I can and kind of whittle the problem down to the most simplest form possible, okay? How could I rewrite cosecant? How could I rewrite it, y'all? 1 over sine. Good job. I've noticed I'm still dividing. How can I rewrite cotangent? What would be beneficial? Excellent. You are so happy. But if I skip a step, then I'm going to write what in the middle? Okay. Y'all go ahead with your bad selves and skip that step. You make a careless mistake, and I'm going to write an ugly little note on your paper. Told you. Ugly. Real ugly. Mark them all out? Uh-huh. I thought. Exactly. 1 over cosine x. 1 over cosine x is what, y'all? Secant. Random. Holy moly. Questions at all? This is easy. It's going to get more difficult. No. What's your question, Amber? No, I have not.
The only thing I keep not getting is how do you start on the problem? Like, I never know how.
Stop talking.
Like for the last one, like the one before that and everything. Like I see like the beginning of it, but I don't know how to start out. Like you have cosine x or sine x. I don't know. I don't know.
How I went from cotangent to cosine over sine?
Yeah, and then you got cosine over 1 and sine over 1. Like you just put them in those little.
I just wrote them as a fraction.
That's it. That's how you're doing.
Yeah.
Okay. And you have to follow the order of like how it's getting.
Yes.
Okay. So,
Yes.
okay. Done.
Okay. All right. Pardon? Yeah. Yeah, this is going to be good. Here we go. Here's another one. Oh, y'all huffing and puffing. Y'all are so pitiful. Cosine squared. Neither am I. Do the work. No, you're not. You're running your jaw, being smart. I am not in my house. You don't back talk. You don't. Ugh. Now, I love you. Look at your card. See if you got anything on that card that will take care of cosine squared, or do you have anything that will take care of that tangent squared x plus 1?
1 minus sine squared t.
All right, that's a lot. You said something, but Matt, what's this right here? Tangent squared x plus 1. Do you have an identity? Squared. Attaboy, Matt. Secant squared x times.
Wait, what? That's a mom.
Tangent squared x plus 1.
I have mom.
It's not, it's supposed to be a plus.
Okay.
Is that what y'all have on your cards? Okay, secant squared x is tangent squared x plus 1. Yes. Okay. Now, what can you do?
Can you
Do I need to? All right. Can I rewrite anything? Can I rewrite cosine squared? Are these two related in any way, cosine and secant? How? Why? Ah, here we go. 1 over cosine squared. And now what? How do we start with that and get to a 1? Y'all, for real? Like that. I know that. Smart honeys. No, there's still a 1. Because 1 goes into 1 one time, 1 goes into 1 one time, it's 1. It's not 0. Okay? We have to multiply by 0 to get 0. Comprende? One more. One more. Lord, you'd think we've done 500 problems today. Y'all are pitiful. Having to work's killing you.
We got 8.5 days.
8.5 days left. You know, it's been the only year I've never counted down.
I told you to count down.
Pardon?
But when we get out, we don't count down.
I know. I can't believe I haven't done it. I should. Hey, do this problem. Hey, simplify the left side. Wow. Okay. How can I rewrite secant? How can I rewrite this quickly? 1 over cosine times cosine over 1 minus cosine squared. Just let that sit out here, let it hang out, just see what's going to happen because, of course, your cosines are going to cancel and you get 1 minus cosine squared x. Where do we go? Card. What is 1 minus cosine squared x? Sine squared x. And everybody got here, and then you were like, what do I do? Just look at your card. Just chill. It's very simple. Very simple. Okay? Questions at all?
Is there going to be a lot of homework?
Yes. There is now. You take care of your friend back there. Here we go. Oh, yeah, we'll leave that one for tomorrow. Oh, y'all are going to love those. Folks, look at page 242. Oh, well. What a friend. What a friend. I want you to do page 242, 1 through 6. Folks, and I will not be in here, you're still going to turn this in?